Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 12, Unique Triangles, Two Sides and a Non-Included Angle. Two sides and a non-included angle. Okay. Exploratory challenge. Use your tools to draw triangle ABC in the space below, provided that we have side AB that's 5 centimeters in length. BC is 3 centimeters in length. And angle A is 30 degrees. So I'm going to draw, since I have an angle A and I have a side with that end point, I'm going to do AB first. Everybody understand that? No need to draw BC right now because I'm not going to put angle A at this location because that's endpoints B and C. So I'll put angle A at the end of segment AB. So the first thing I need is a ruler. I don't know why this does that, but anyway. Okay, so here's my ruler, and I'm going to draw a line segment 5 centimeters long and call it AB. So right there, 5 centimeters, and I'm going to label it 5 cm, and this is A, and this is B. Okay, so done. Now I need a 30-degree angle at A. So I get my protractor, and I put my crosshairs right there on A. So the crosshairs got to be on A, and the line that's at 0 degrees has to be on the segment AB. And I'm going to put a dot over here at 30 degrees, which is approximately right there. Okay, so now I take my ruler, and I'm going to cheat because my ruler's got a built-in compass, so obviously we can't do that in the real world, but in electronics we can. So I line up my point A, and I draw a line segment. I don't know how long it's going to be, but I do know that this is 30 degrees. Okay, so now what I'm going to do is I'm going to show you that in order for us to create a triangle now, we need a side length of BC of 3 centimeters. So I'm going to draw that down here. And I'm going to make it 3 centimeters long, like so. Okay, so now I'm going to take it, and I'm going to name it. First I'll name it. So let me put B over here, and let me put C over here. So this is BC. Let me put dots on the ends there. Okay, so now what I'm going to show you is that if I rotate this and put B right on B, I've got to find a place where that is going to touch the blue line. This is not easy, by the way, electronically. So if I put that right there, notice it's too long. It's overlapping. It would get cut off and it'd be less. So I need to rotate that until I can find where it would be. Now the easiest way for me to do that would be to get a compass. So if I drew this line segment, so say I drew this line segment, and now I'm going to get a compass. Let me get rid of this dot here. So I'm going to get my compass out, and I'm going to bring it down, and I'm going to put it right on C, and I'm going to open it up to B. Okay, so what I'm doing there is creating a circle with a radius of BC. See what I'm doing there? Now I'm going to move this up to B here, and I'm going to draw a circle. And notice what just happened. Okay, so there's my circle, so I'm done with my ruler now. So what that means is that if I drew a line segment from B up to here, this would be 3 centimeters, just like it said, but I could also have drawn it. Let me do dash for this one. I also could have drawn, oh, that's not what I want. Alrighty. How about a segment dotted from B? I could have also drawn it over to here. Right there. Okay? So AB was given, it was 5 centimeters. The measure of angle A with this blue ray and the red ray creates a 30-degree angle. But for me to have a non-included side, the angles, if the angle's not in between the two sides we know the lengths of, then we create two different triangles, because this is 3 cm and this black dashed line is 3 cm. So I was able to create two different triangles, so therefore not unique. Interesting. Okay, so A says, what is the relationship between the given parts of triangle ABC? Okay, well, the two sides and a non-included angle were given. They were provided. Okay, two sides and a non-included angle. B says, which part of the triangle can be drawn without difficulty? Well, what was I able to draw easily? The one side, side AB. So I'd say side AB, or the segment AB, and angle A was easy. What made the drawing a challenge? Okay. What was difficult was side BC. Okay, it was difficult to draw side BC, so let's go back. Okay, drawing AB was easy. Putting my protractor on A and drawing a line at 30 degrees was easy. But then it was like, uh-oh, now I had to draw a segment 3 centimeters long, get a compass, measure it, put that compass at this point here, draw a circle, and then realize that there were two locations on the blue ray that would create a triangle with sides 5 and 3 with a non-included angle of 30 degrees. Okay? So, step C says, a ruler and compass are instrumental in determining where C is located. Even though the length of segment AC is unknown, extend the ray AC in an anticipation of the intersection with segment BC. Extend AC. So that meant just to extend this. You don't know how far it's going to be. Somewhere on there, BC is going to land, so that's what I did. Okay. Now it says draw segment BC with length 3 away from the drawing of the triangle, which is what I did down here. Okay, and then adjust your compass to the length of BC. Draw a circle with center B and radius equal to BC, or 3 centimeters. And that is what I did up here. Okay. D says, how many intersections does the circle make with segment AC? 2. What does each intersection signify? Okay. What does each intersection signify? And that was C. Okay, let me try to make that more legible. Okay, so each signifies a possible location for point C. Complete the drawing of triangle ABC. Did the results of your drawing differ from your prediction? Okay, so the only thing I'm going to change here is I'm going to name this C sub 1 and this point here C sub 2. And then once I'm done, I can move this circle out of the way as well. So you see there are two possible triangles. So there you have it. So you would have to answer this question yourself, because I don't know what you predicted. So I will just move on. All right, number 2. Now attempt to draw a triangle DEF in the space below, provided, and I like color coding, DE is 5. So let's just start with DE being 5. So put my pencil here, draw it there. It's 5 centimeters. Label it 5 cm. Call this ND and this NE. Check. EF is 3. Don't know where it is. Angle F is 90 degrees. So I'm going to get my protractor. Angle F. Okay, so you see what I did there. I drew the first one, and angle F is on segment E, or it's formed by one of the rays, EF, not DE. So this is going to be my compass location. So now I need to draw EF first for my triangle. So my triangle, I'll get this out of the way. I will put triangle EF over here. So it's going to be 3 centimeters long, and that's 3 cm, and this is E, and this is F. Okay, so this is done, and now I need a 90-degree angle at F. So I put my protractor right on F so that my crosshairs are right at the end point, and the line segment is on 180 degrees. I'm going to go up and place a dot at the 90 degree right up here. Move my protractor, get my ruler, put it right on the end at F, and I will make this green, and I'll draw a segment up like so. Okay. So there's my right angle, and there's my sides. So now what I need to do is take my compass and place it right on E. Notice we have E here. So I'm going to place it on E, and I'm going to open it up to D. Let me just move this just a little bit there. That looks pretty good right there. So what I did there is I opened my compass up so it has a radius of 5 centimeters. And there would be the circle. Okay? So I'm going to take this over here and place it on E, and I'm going to draw a circle that is 5 centimeters radius, and at this location is the only place it crossed the green line segment. So then I'm going to take my ruler, put it right on E, rotate it to that dot there, and there is my point, and that is point D. This is 90 degrees. Okay, so it says attempt to draw triangle DEF in the space below. Continue with the rest of the problem as you work on your drawing. All right, so what did I do? I drew EF, which is the point that has the name of the angle in it, or I'm sorry, not the point, the segment that has the end point of the given angle. First, draw a circle. Now draw a 90-degree angle with my protractor at the endpoint F is 90 degrees. And then I drew DE, which is the side length 5 off to the side, used that to open my compass up 5 centimeters, placed it at E, rotated it, and found where it intersected the green segment that made a 90-degree angle with EF. And there is my right triangle, and notice it only created one. So how are these conditions different from those in exercise 1? Do you see the criteria will determine a unique triangle? Okay, so the provided angle was an acute angle in exercise 1. Now the provided angle is a right angle. Possible prediction. Since the same general criteria, 2 sides and a non-included angle determine more than one triangle in exercise 1. The same can happen in this situation. That would be your assumption before drawing it. Now B says, what is the relationship between the given parts of triangle DEF? So again, 2 sides and a non-included angle were provided. C says, describe how you will determine the position of DE. Okay, so I would say I will draw a segment equal to length to DE, which was 5 centimeters. and adjust my compass to this length. Then I'll draw a circle with center E and radius equal to DE. This circle should intersect with the ray FD. Now D says, how many intersections does the circle make with FD? Well, that one's an easy one. There was only one intersection. Complete the drawing of triangle DEF. How does your outcome differ from that of triangle ABC? So in drawing triangle ABC, there are two possible locations for the vertex C, but in drawing triangle DEF, there was only one location for the vertex of D. And part F said, did your results differ from your prediction? That I can't answer for you. They're your results, not mine. Okay, number 3, it says, now attempt to draw triangle JKL provided KL is 8 centimeters. KJ is 4 centimeters. And angle J is 120 degrees. So use what you drew in exercise 1 and 2 to complete the full drawing. So this should get routine now. We're given 2 sides and a non-included angle. And the angle's name is J. So I look and see which segment or which line segment has the letter J in it, and it is KJ. So I will draw the 4 centimeter KJ segment first. So I'll draw it right here. So there's a 4 centimeter segment, and this is K, this is J, and this is 4. That's weird. It didn't undo my 4. Okay, anyway. Okay, so 4 centimeter section called KJ, segment called KJ. There it is. Then I get my protractor. And notice how much quicker and easier it is once you've done a few of these. Hopefully you're doing this quickly or catching on so that it's not confusing or you're stopping saying, I don't know what to do next. Okay, so I need 120 degrees at J. Well, I don't want this 120 here. That is acute at J. I want to go out here to this 120. So I'll put a dot right about there. Okay, right about there. And move my protractor out of the way and cheat by making this 60, because 120 plus 60 is 180. And when I put that here, notice it, oops. Okay, so I'll use blue because I circled the angle J with blue. So there is my segment going up, and this is 120 degrees. Okay, so I have the segment KJ 4 centimeters and angle J 120 degrees. Those 2 steps are done. Now I need to draw a segment. Let me just make that over here in red, 8 centimeters in length. Okay, so there's an 8 centimeter segment. I get my compass and place one end here. And the other end down here, like so. And of course, if I drew a circle, it would look like that. All right, so now, where does this go? Where do I put this? Well, I want side length KL. I don't have L, I have K. So I know where K is, I've got to find L. So I'll put this point on K. Like so. And then draw a circle around and find where it intersected. And just like the 90-degree angle, there is only one intersection right there. So then I'll take my ruler and draw the segment right there. And this is L. Okay? So I'm going to show you something. This should rotate. And then if I moved it over here, made it parallel first, and then moved it, see how it's the same length? Rotate it a little bit, but you get the idea. Okay? All right. So there you have our triangle. Number 4. Review the conditions provided for each of the 3 triangles in exploratory challenge and discuss the uniqueness of the resulting drawing in each case. Okay, so we would say all 3 triangles are under the condition of 2 sides and a non-included angle, all 3 times. The non-included angle in triangle ABC was acute, while the non-included angle in triangle DEF was 90 degrees, and the non-included angle in triangle JKL was obtuse. The triangles drawn in the latter 2 cases are unique because there's only one possible triangle that could be drawn for each. However, the triangle drawn in the first case is not unique because there are 2 possible triangles that could be drawn. Okay, so that is the end of lesson 12. Review the lesson summary and go to your problem set.